Start section 6.2, which is titled Theory of Evolution by Natural Selection. So I'm going to talk about Charles Darwin and his theory of evolution and what exactly that means. And then tomorrow we'll dive into adaptations and variations, which will kind of set you up for a little project later on this week where you'll select an animal and talk about its adaptations, its characteristics or traits that allow it to survive in its unique environment. And then on Friday, you guys are going to have a quiz on 6.1 to 6.2. Now, Thursday, I will be here, but I won't be here. I'll be in the school building, but I won't be in my classroom. I have a training that I have to attend to with Mr. Lanter and a few other teachers. Yes?
Can Miss Rich come?
I don't know, because Mrs. Folson will be gone, I will be gone, Mrs. Minging will be gone,
Mrs.
Steele will be gone, so there's going to be a whole bunch of subs and just a lot of subs in our school on Thursday.
If Mr. D is our sub too, I'm going to have an MI for your class.
Okay. Anyways, the theory of evolution by natural selection. So the first thing I want to talk about is what the word theory means. We tend to use it differently in science versus everyday. So like in everyday, when you're like, in theory, you know, it might be a point of view or belief system or a guess, okay? But in science, a theory is basically fact. It's based on evidence. It's not some hypothetical situation. There's a lot of evidence for that explanation of events that you're seeing. So it's well supported, it's documented, backed by lots and lots of data. And really the only way to unshake the theory is to, come across something that doesn't fit with the theory. So for example, we learned about the cell theory in this class, right? The 3 statements. Do you guys remember the 3 statements?
Cells are the building blocks of life. Cells create all living things.
Cells come from other cells.
Exactly. So there's 3 statements. Cells are the building blocks of life. All living things are made up of cells, and cells come from other cells. Until we come across a living thing that is not made up of cells, that theory holds, or that statement for that theory holds. Until we witness cells come in from some other origin, that statement will hold. Okay, so theory is based on tons and tons of evidence. Can we think of any other scientific theories that we may not have discussed, but maybe you've heard about, maybe in the news, or you just came across it, or... Nope.
Does Fifth Hour have anything?
Yeah, they did, actually. They had quite a few.
It doesn't have to be about cells, just...
Nope, it can be about any theory.
Newton's law.
That's a law. It's different from a theory. Laws are mathematical expressions. All right, Einstein's general theory of relativity, for one.
What's that?
String theory, E equals mc squared. String theory, something to do with multiple universes. The Big Bang theory, because then we started talking about the TV show Fifth Hour. So, yeah, so those are just a few theories. So, in science, theory is basically like fact until it's like disproven. The reason why I want to discuss the definition of theory is, whenever I introduce the topic of evolution, kids kind of squirm in their seats, right? You're like, oh, we're talking about evolution, and one of the refutes, or I always hear in the classroom is, well, it's just a theory. And I'm like, no. In science, theory means something different than everyday language.
So
Okay.
then what would you say for, like, if it wasn't a theory, like, for science?
A hypothesis.
Oh.
Because you can disprove a hypothesis. Okay, so moving on to Charles Darwin. Charles Darwin, who was he? Well, he was an English naturalist. A naturalist is someone that studies plants and animals by observing them. He did this, he was around during the mid-1800s doing this. He just loves science, loves nature, was kind of an amateur geologist. Someone that studies rocks. He was kind of into rocks too. Now, he's not the first to develop this theory of evolution, which just means change over time. But his theory is the one best supported by evidence. And for that reason, he's responsible for the theory of evolution. So he wasn't the first to have the idea, but he's the one that provided evidence for it and how it happened, kind of explains it, and therefore Charles Darwin is credited for the theory of evolution. So who was he? He was an English naturalist. What did he do? He's the one that proposed the theory of evolution based on evidence.
Who developed the theory of evolution?
Okay. His great-grandfather, Erasmus Darwin, had an idea. There's been tons. Lamarck had kind of this, I don't want to say it's a crazy idea, but he thought that animals could change in their lifetime. So for example, let's just say that I was a giraffe and I needed to reach the leaves at the top of a tree. If I stretched my neck and I just stretched my neck every single day, my neck would get longer and I could pass that on to my offspring. That was his kind of idea of how.
Wait, so he was the first to have evidence?
Yeah, the one that provide evidence for it. Yeah. Okay, can I move on?
Yeah.
Yep.
Okay. So the story starts with the voyage of the Beagle. Charles Darwin in his early 20s, I know that previous picture does not depict him in his 20s, but when Charles Darwin was a young man, he didn't really know what he wanted to do with his life. Okay. His family had a long history of, going into becoming a priest. He kind of wanted to be in the medical field. Maybe he thought about being a doctor. But I have read some books saying that Charles Darwin, like when he saw blood, he would faint. Can't really be a doctor if blood kind of makes you faint. But the university, Cambridge at the time, encouraged him to kind of go into geology/nature because he was really good at making observations. So anyways, in his early 20s, he's like, I don't really know what I want to do with my life. Well, his friend was taken off for a voyage around the world. And he's like, hey, why don't you come on this trip with me and keep me company? So his friend was, the captain of the ship, but, he wanted to have intelligent conversations, and the people that, run the ship are not that intelligent. So he wanted Charles Darwin to kind of just, have these deep philosophical questions, conversations with him every night. So Charles Darwin's like, heck yeah, sure, why not? Let's go on a trip. So they go on this trip around the world. And one of the pit stops was the Galapagos Islands, which you can see is off the coast of South America, about 700 miles. Okay, so you zoom in, lots of little islands here. There's the Google map image. And Charles Darwin noticed that each island had a slightly different environment. One island was lush and tropical. Another island was very desert-like. Another island was grassland. One island was super mountainous. One island was pretty flat. I mean, they just had all these different habitats. And he noticed that there were different types of tortoises, mockingbirds, finches. Finches are another type of bird on each island. And they were different enough to be classified as different species. So Charles Darwin, on this voyage, would collect plant species and animal species, and he cataloged them and stored them in the boat. And when he got back to Great Britain, okay, he dropped them off at a museum, and he's like, hey, can you take a look at these new species? And the person that analyzing all the, the birds, the mockingbirds, the tortoises, he's like, these are all the same species, yet they look really, really different from each other. Charles Darwin was like, what? No. They have to be all different species. No way. There's no way that they're the same species. Okay? I'll show you a few pictures here. So take a look at tortoise here and the tortoise down here. I know you can't really see the picture or the lights here, but what are some differences you see between the two?
One has a long neck.
Yeah, one has a long neck. The other one has a very short neck. Okay? Charles Darwin thought, hey, these are two different species. They're not.
The shells.
The shells are different. Excellent. What about the birds? The beaks. These are finches. Okay? The beak of the finch.
Is one of them eagle?
They have different sized heads.
Different size heads. And that's probably because of the beak. They have to have thicker muscles to work those larger beaks, right? So he noticed that there were variations, slight differences among these species of birds, as well as tortoise. Okay, where'd my little thing go?
It's gone.
Where'd it go?
It left on the trip.
Went on a voyage around the world, huh? Oh no, where'd it go? Try this again. There it is. Okay. All right. So one of his observations that Charles Darwin made was that there was a relationship between the species and the food sources of the island it lived on. So one of the big differences we saw with the tortoises was its neck length. Tortoises that had long necks used their long necks to eat the tall cacti. Tortoises with short necks used their short necks to eat the short grass. So there was a relationship between the species and their food source. Same thing with the finches. Finches that had large beaks would feed on large seeds because they were strong enough to crack open. Okay. Finches with small beaks fed on small seeds as well as tiny little insects.
How did it not hurt their mouths to eat the cacti?
The thorns of the cacti? Are you talking about the thorns of the cacti? Or what do you mean?
It says their necks are long enough to eat the tall cacti. How'd that not hurt?
Oh, I see. They have some adaptation that allows them to just, I don't know. Maybe that's something you could look up this week on our project. All right, can I move on? Okay. So here's another picture just showing the variations of the tortoises and the islands that they could be found on. Okay, so if they're all basically the same species, okay, Charles Darwin's like, okay, where did they come from, right? So he's like, maybe they all share a common ancestor, and then over time they changed and adapted to their environment, and that is why they look extremely different from each other. So maybe they shared a common ancestor that came to one of the islands millions of years ago. For a Galapagos tortoise, I don't know exactly how a tortoise could get there. A big storm, maybe it got on a fallen tree or some kind of land-made craft, it just floated and he just hitched a ride and he saw a bunch of islands. He's like, I'm getting off. This cruise is over. With finches, there's been documented instances where birds have been swept up hundreds of miles away from a site, with the strong winds. So with finches, it's 700 miles. Maybe they just got swept up in a storm. Yeah. Okay, see ya. Okay, moving on. So these slight differences that we see are called variations. It is an inherited trait, which means it can be passed on to the offspring, and it occurs in members of the same species. So these snails, you see lots of different variations there. Zebra stripes, lots of different variations there. So Darwin thought of another question. Hey, how did these neck lengths and shell shapes of tortoises change to match the island's food sources? Same thing with the finches. How did the finches' beaks change to match the island's food sources?
Do you have to write the question on the bottom?
No, it's just kind of a segue into this next slide. All right, so at the time, we're in the 1800s. Darwin didn't know anything about genes, didn't know anything about DNA, okay? But he realized that there were variations in populations. So he wanted to explain how different species of tortoises could evolve. So he started to make that connection between the variation, which is the trait that, the long neck, and the food source. So he's like, okay, food is a limited resource. People compete for food. Animals compete for food. I don't think we compete with food that much anymore, but you know what? There was a time when humans did compete for food. So members of a species in the same area will compete for a resource, in this case, food. If a trait or some type of variation benefited, in this case the tortoise, well then that tortoise is going to have an advantage. They're going to get the food. As a result, they're going to be healthier, they're going to live longer, they're going to reproduce more, and then pass on that variation to offspring. So then maybe in the future you see longer necked tortoises. Edwin? Oh, I see. Gotcha.
I usually see short.
And that could be a swing to short grass. Maybe there's not a lot of tall cacti
I
anymore.
don't even see like big ones like that. I just see tiny ones.
I just came across a news headline this past weekend. There's a tortoise that's like 138 years old. So that means when it was born, when it was 32 years old, the Civil War was going on. Kind of crazy.
What was he doing?
What?
What was he doing?
I don't know what that tortoise was doing.
Just hiding?
Probably just chilling out on the Galapagos Islands.
And then just hear gun sounds. He's just right there.
Off in the distance. Right. Okay. So how do species change over time? Natural selection. So natural selection is this mechanism that drives evolution. This is the book definition. You can see it's really, really long. But the gist of it says, hey, if you have a variation that helps you survive, then you'll live longer, you'll compete better, and you'll reproduce. And then, as a result, the next generation might have more of that variation. So if you have something that gives you an advantage, then you're going to survive better than others. There are 4 basic steps, or 4 things, or 4 factors that you have to account for in order to call it natural selection. First one is, well, I guess I should list variation first, but variation. You have to have differences. They have to be heritable, which means passed on, and they have to occur among the same species, basically. Reproduction. That trait has to be able to be passed on. Competition. That variation allows that individual to survive, kind of gives it that edge. And then finally, selection. Over time, more individuals have that variation. So I'm going to show you a scientifically incorrect example of natural selection, but I think it helps to get the point across.
Didn't you do like a thing with the sophomores last year during quarantine where it's like you entered in a couple traits and then like it would show you over the years?
Yeah, who wants to win? Who wants to live a million years? Didn't we play that game in here?
No.
We have not.
I watched Leslie do it last year.
Cool. Maybe I'll get the Mac Airs and we can play Who Wants to Live a Million Years. It's a fun game.
Mac Airs.
Mac Airs.
What's that?
They're like laptops.
Oh, I think there's something else.
Okay, so here's my scientifically incorrect. Let's take a look at this variation among clownfish. What do you see different among one of these clownfish? One of them's smiling. Thank you so much for saying that it's smiling. Everyone else says it's a mustache. Ah, yay. Yes, it is a smiley clownfish. It's supposed to represent that he's funny. Okay? So you can see these 2 clownfish, they look kind of pissed off, right? And this one, that is a smile, not a mustache. Now you can't see the mustache. You can just see it. That's all you see now is a mustache, right?
No, I still see it. Yeah, oh yeah, I still see
You still, yeah, you see a mustache. You don't see a smile. I know. Okay.
it. I actually see
So
it.
that's the variation. A funny clownfish. Serious clownfish. I'm going off of Finding Nemo
Wait,
here
what's
with
that?
Marvin.
The
Serious.
one- the
Oh,
with
this
the
one?
glass face.
He's dead. Okay, so here's my competition. The funny clownfish is swimming, right? And you see his serious clownfish dead. Here's a shark. Tell me a joke or die. So good thing he's a funny clownfish. What did the fish say when it swam into a wall? Damn. Ha ha, you live because you are funny. So the funny clownfish lives and goes on to reproduce. The eggs are not to scale. And then, over time, you see more funny clownfish. The end.
Oh,
Okay, I guess I can tell you a true story about natural selection. You guys want to hear that instead?
no.
Wait, could you go back a page?
Sure.
Is that it for notes?
For notes, but I'm not done per se.
Reading?
No. I just want to talk about.
Loud enough
Miss Erickson, what are you wearing tomorrow?
I don't know.
I might be wearing pigtails.
Cool.
I might not be even here tomorrow.
Okay, I need a new slide because I just realized. Yeah. Okay. This is gonna be really bad, guys. I don't know if I should do this. Okay, back to my full screen. Dude, don't do that. Yep, this is gonna be bad. Okay, imagine this is a graph, and this means 100% of the population. Like that's good. That's like the number of people. And down here is 0. That means death, right?
Dead.
That's supposed to be a percentage. And let's say that this is 7 millimeters, and over here we have 12 millimeters. And this is supposed to represent the beak length, or beak size. That's a beak,
Bird.
because I don't want to write beak. Okay, everyone understand my graph so far?
Yes.
Okay, so I have beak size down here. This is small, this is large, and this is the number of individuals. So let's say you come across a graph like this. Hey, that's pretty good. So what would you say is the average beak size according to this graph?
100.
The beak size.
Oh.
Like what number roughly?
9.
About 9, thank you so much. Okay, so let's say that this is like normal conditions on an island, adequate rainfall. You know, the average beak size is about 9. We do have some individuals that have small beaks. We do have some individuals that have some large beaks. So the majority of the population is around 9. Okay? Now, same graph, but let's say that this island goes through a drought, okay, where there's only large seeds. What do you think is going to happen to the average size of the beak?
Small.
It's going to go down, but there's a drought. So there's only large seeds.
Oh, that is good.
Then it's going to go up. Okay? So now you're going to see a shift in the graph like this, where you'll have you'll have more finches with a larger beak size than you had before the drought. Okay? So that's kind of how natural selection works. Nature kind of selects for the trait based on environmental conditions. So those individuals that had the variation of a large beak were able to survive, reproduce. As a result, you might see larger beak sizes. If the next couple seasons it was rainy, then which direction would you see our graph move? Down, and you'd see more individuals with a small beak size versus a large beak size. So it changes. And the reason why I mentioned in this is that there's a pair of scientists, a husband and a wife. Their last name is Rosemary. They go back to the Galapagos Islands every single year. They've been doing this for over 40 years. They capture every single finch on the island. They measure the beak size. They measure the length, the mass. Record those that lived, record those that die. And they have evidence that shows the fluctuations of these beak sizes.
It is still alive.
Yes, they are still alive.
Can you imagine doing that every year and like talking and being like, oh yes, Susan, we're going on our yearly Galapagos trip.
Yeah. They do, and they bring their students with.
Imagine,
Yeah.
finches.
Okay, so your assignments are the Darwin B Questions. You can find all of your answers in your notes. Okay.
Number 4.
Yes, it is. You need to look for the keyword relationship, and then you will find your answer. Okay?
Wait, what does it mean by realize, explain? Is that supposed to be a comma?
What relationship did Darwin realize explained the type of species of tortoises on the island?
When he explained it?
What relationship did Darwin realize explained the type of species of tortoises on the island? I don't know. I got that from the book, so they didn't have a comma. I don't think the book's wrong. I mean, on that one. They've been wrong